oil palm. And, in jute, if you know, in Philippines, they have some kind of barong from pineapple fiber. Call it the traditional cloth, barong. I thought they call it barong. Okay, so this is the 4F that is the product of agriculture, but the production of this agriculture really depends on many factors. But what we are going to talk now is on how the agricultural technologies, how machinery, how AI, how IR 4.0 can help to increase the production of our food. So this is really important because the world population is increasing. Okay, it is estimated that 10 million people will be on the world, on Earth by 2050. So more food is on demand. So we, like myself, because we are working in agriculture, we are under pressure to increase the yield, but we cannot increase the land size. Okay, so this is the common challenge that is dominated. This is in Malaysia. It is dominated by smallholders, but it is also, I think, the same in the Philippines, in Indonesia, where smallholders, they are elderly, they are not very excited to learn the new technology. Okay, they like to do the way what they have done before. So this caused the adoption of technology a bit delay, right? So, and then land size is not increasing for agriculture because we have to give away for development, for industry and etc. So, and climate change is another challenge. So these all problems have to be solved with the assisted by AI. I will say AI, okay? The precision agriculture, then etc. Okay, next slide. Okay, so this is an overview why we pay special attention to paddy in Malaysia, because this is our staple food. And if you look at the data there, we produce about 2.7 metric million ton per year, harvested from 600,000 hectares of rice all over the country. And then this is to feed 32, now it's 32 million people in Malaysia. But still it's not enough, okay, because this is just around 70% of our self-sufficiency level. So we still import rice from Thailand, Vietnam, India, okay. So then our average is about 5 to 8 tons per hectare. And in Malaysia, we plant, we grow paddy 2 times a year for now, okay. But there are push to grow paddy 5 times within 2 years. So we are going to increase the planting cycle within a year. Okay, next. So this is where the area, the growing area of the paddy, then you can see that even though this is within the same country, but the yield is changing, yeah, from place to place, depending on the agronomic practices, depending on the soil type, on irrigation scheme available. So, but the national average is about 7 tons per hectare. Okay, next. So, and then this is a comparison between rice and oil palm. This is 2 main crop in Malaysia, either rice or oil palm. Rice is for our security crop, it's a staple food, while oil palm is our golden crop, mainly for export. And then this is fact and figures. So the government, the industrial sector will focus on these 2 crops. We also have cocoa, pineapples, and a few other crops. But this is 2 that we pay attention, special attention on. Okay, next. Then this is a comparison where we are, because some of you may be from the Philippines, from Thailand, from Vietnam. So we can see here that Indonesia is the biggest producer of rice in the Southeast Asian. We have 45 million, but this is data from 2019. And then the average for Indonesia is about 3.3 So you are doing well in terms of paddy production. And then Thailand also produce a lot with the average yield is about 2.0 to 2 hectare, 2 ton per hectare. So this is where we are in terms of paddy production. Okay. Okay, next. So this is the problem. For Malaysia, we want to achieve 100% SSL, meaning if we consume 100 ton of rice per year, so we want to produce 100 ton per year. But the current situation is we only can produce 70%. We still import the remaining. Okay, so this is the issues in the paddy field where you will involve later. If you work in agriculture, if you work in as a, computer science and you work in agriculture, this is the issues that we have to tackle, and some of them can be tackled with AI. Say, for example, a threat of pest and disease. And nowadays, if you see, we have real-time detection, real-time spraying system, and etc. We use the computer for the programming, etc. And then fertilizer. And my part as an agriculture engineer, we look special on the limited technological application. We encourage people, we go and see elderly to adopt the technology, okay? And then aging farmers, labor shortage, this might be beyond our control. Declining number of arable land, they have to do like rehabilitation of the land, scarcity of water resources, especially due to climate change, okay? But some of the points are, can be solved using the technology. And then some of them we have been trying to solve using the AI technology. So I put a question there, where can AI be applied to solve? So in any aspect, it is possible. Okay, next. So the challenges is that we cannot expand the land area for agriculture because Malaysia is a small country. We also have to give away for other development. Okay, so limited suitable land and expensive investment required. You know that I think all of you, since all of you joining this program, I think you have a background. You know something about agriculture. Okay, so agriculture, they require water, irrigation. So the same thing with paddy, you cannot simply grow paddy without water resource. Okay, we need infrastructure, we need irrigation, we need canal. So paddy production can be increased if we increase the yield within the existing cultivated area. Say for example, in Malaysia, we have 600,000 hectares. If now we can only produce 5 ton per hectare, so we have to do something. How? From 5 ton per hectare, we can increase to maybe 8 ton per hectare. Maybe we have to reduce losses. We have to reduce pest and disease infection. We have to use a better variety, drought tolerance variety, for example. Okay, but we cannot go with bigger size. That is the size that we have. And then the strategy can be implemented either by planting high-yielding varieties, good varieties, or we go by adopting good agricultural practices. This point comes under management and comes under engineering. So where we all are working now on that topic, on that aspect. So the scope of GAP will cover correct type, amount, placement. This is all engineering. This is all need sensors and placement. Okay, and appropriate type and size of technologies and efficient management of the farm so that yield can be increased while field loss can be minimized. This is two things. So as somebody who work in agriculture, you can increase the yield, or to maintain the yield, you should also reduce the loss. Okay, so this can be done by PA, mean precision agriculture, or AI is smart sensing something. Okay, so next. So this is newspaper cuttings in my country highlighting that we have a labor shortage. You know, in my country, previously, even now, we still rely on foreign labor, especially from Bangladesh, to work in our oil palm, in our paddy, but they are not sustainable. At any time, they can leave the country. So we need to find a new labor. See? Okay, so this is a pressure in the country that we should go for mechanization to replace or to reduce our dependency on foreign labor. Okay, next. So the government has come up with a plan, is with a policy. We call it National Agri-food Policy, where the increasing use of automation, mechanization, digitalization, AI, whatsoever, is a part of the planning. So we at university, we work with government agency to make sure that policy is implemented. Okay. So next. Okay, so I think all of you should know this. If you are saying that you are agriculture, you love agriculture. So there are different type or a few types of technology or technologies, yeah, for agriculture. The first one is mechanization technology. This is my area. Okay, and then we also have automation technology where we automate machine, and then robotic technology. And I think this is very common now. It's growing area. Under robotic technology, we have two types: UAV or drone, unmanned aerial vehicles. We also have UGV, unmanned ground vehicles, like autonomous machine. You look at the picture next to it, and there is UGV that we use in oil palm plantation. It's like unmanned. It's like autonomous vehicles we can deploy in the oil palm plantation for spraying, for fertilization and something. And then the next one, we have a smart farming, the use of sensors to replace human observation, or also precision agriculture, which they mainly use the technology of artificial intelligence for making decision. Okay, to extract data, to analyze the data, to make decision, and then to activate your we call it an effector, your sensor to activate a pump to irrigate or something, right? So that is the connection. And then what can AE? AE here mean agriculture engineer, because I know some of you is not engineering, but okay, what can we do about this? What technology is suitable for us to adopt? Okay, so that in this context, the paddy production can be increased, right? And then nowadays, it is very popular terms, is IR 4.0, industrial revolution, where AI is a part of it. AI is the enabling technology for IR 4.0, on top of autonomous vehicles, on top of smart sensors and etc. Okay, all right, next. So this is the reason. I'm not going to read it one by one, but you will have the slide anyway. So meaning that there are reasons why we have to adopt the technology, especially when we are lacking of labor, the farm workers. So this is all the point where why we have to adopt the technology, a suitable technology, okay, to reduce the burden of farm workers, to increase the production, to have more efficient application of crop inputs, either fertilizer or pesticide and etc. And then the last point that I put in the red color is a platform for adoption of precision agriculture and IR 4.0, where we go for autonomous system, automatic system in the farm. Okay, next. So this is the need. This is specific for my country, but I believe it also applicable to any other country in Asia, right? So in the world, if you look at the statistic, farmers only represent 5% of the world population. So it means that whatever wheat, rice we eat is produced by 5% of people who seriously working in agriculture. This is the statistic. And then majority of them are elderly. Even from in Japan, I heard they also have elderly farmers who still maintain the farm. Okay, so so in Malaysia, we have 32 million people. We only have around, I say, 45% of them are youth. Okay, and from this amount, from this number, only 15% involved in agriculture. So we still have to do something to encourage young brain, young people, young generation to involve so that you bring in new technology. Okay. So, but it is common why our people, our student doesn't really like agriculture because they might see this industry as difficult, dangerous, dirty, demeaning. You will expose to direct sunlight, snakes, whatever in the field. So that will keep you away from the farm. Okay, but this is what we have to deal with. So by hook or by crook, we still have to produce the food, so we have to modernize the traditional way of doing farming with all the technology we mentioned before, so that that industry will be more appealing to people to join in. Okay, so what we are going to modernize, or what we should modernize, is number one is mechanization, very basic, replacing human labor with at least with a tractor. Okay, and then some work, some tasks might be difficult to be done, then we can automate. Okay, and then we use smart system, artificial intelligence for like automatic detection, automatic spraying, smart irrigation, and etc. And then digitalization, when we don't have to record everything on a paper base. We record everything with sensors, and then it will be automatically analyzed in the microcontroller or something. Okay, so next. Okay, so this is why we say that it is very important for us to modernize our agriculture sector, and then we have to use the digitalization technology to modernize the agriculture, so we can reduce dependency on labor. Okay, so next. So I think all of you must have heard about Industrial Revolution. It's about connectivity, how sensors to sensors connected, how sensors to device connected, and how we can transmit a data. The system is working in the farm, but we can assess their performance in the office, maybe in the remote area. So this is about Internet of Things, IR 4.0. So it's about cyber physical system, Internet of Things. The keyword for IR 4.0 is a connectivity and the data availability. You have the data, and the data generated or captured by the sensor, ongoing sensing. Okay, so as we implement smart technologies in our farm, connected machine will interact, visualize, and entire production chain can make decision autonomously. And then of course, IR will disrupt almost every industry, but that effect in agriculture is remain slow, remain below expectation. So all of you are needed to boost up the adoption of that technology in agricultural sector. Okay, okay, next. And then to achieve that, those who are in working agriculture, they have to collaborate with computer science, people from electrical engineers, people from electronic engineer, right? So that the system is more reliable. Okay, this is about IR 4.0. Connectivity is a key factor for the transformation of IoT as a key enabling technology for agriculture equipment. Then IR 4.0 is not a system, it's just an era. It's a time phrase where there are many enabling technologies available to make it happen. Okay, so for example, for IR 4.0, the main component that make it happen is the Internet of Things, the technology of Internet of Things, big data, and then artificial intelligence. Okay, and then again, IR 4.0 require transformation of production infrastructure. The main thing is connected farm. Connected farm means we have a farm, let's say 200 or 10 kilometers away from here. but we don't have to go there every day. We can monitor everything happen, like crop growth, what happened to your crop, is there any pest and disease appear. Everything is detected online, but you can access the data from your office. That is connected. Okay, and then new production equipment, connected tractors. If you see a photo I put there, is autonomous tractor, where this is developed in Japan. This is from Tsukuba University. They develop unmanned tractor, autonomous tractor and machine. Even in Malaysia, we have developed autonomous tractor for spraying in the oil palm plantation, because we have developed a path. So using a GPS, so that tractor will move and will detect where is the oil palm tree, then they will release fertilizer needed by the tree. Okay, so meaning that technology is possible, is feasible, but again we have to work on how to improve the efficiency of the system, right? So the digitalization of agriculture is based on the development and introduction of new tools and machine in the production. So eventually the adoption of this technology will increase the productivity, the quality of the product, the environmental protection, and also reduce the number of workers needed in the farm. Okay, next. Okay, I think this is just common revolution definition for IR 4.0 is about connectivity where cyber physical system can work together. Okay, next. Okay, so as I said earlier, IR 4.0 is not a system, but is an era, is a time where there are many enabling technologies that can make sensor to sensor connect to each other, talk to each other. Okay, so what are the enabling technologies available now to support that system? The era is we have like artificial intelligence. So nowadays we can simply get, I think the most common like microprocessor you use Arduino, Raspberry, those things, MCU. And then we have a big data analytics, we have smart sensors and etc. Cloud computing, we just have to hire rent the domain from the server, and then Internet of Things, etc. So if you have that expertise, your chance of getting job after graduation is very high, because the world is moving towards that. Okay, next. Right, now the potential benefit of IR 4.0 in agriculture is very huge, and we are exploring that. That's why many countries in Indonesia, in Japan, even everywhere, they are working on that to explore what is the best sensor to monitor the crop growth, what is the best sensor to monitor what mostly on the stress due to drought, due to water stress, and etc. Okay, then we can employ immediate with corrective action so that the crop go back to normal growth punya stage. Okay, so so revolutionize agriculture production through digitalization. Again, I put there ABE, agriculture and biosystem engineers. But in this context, all of you, what would be your contribution to support that idea? Okay, so again, the future farming. Nowadays, if you notice, we have seen many companies, even university, have invested in plant factories so that we don't need a land to grow cabbage, to grow lettuce. We can grow in a plant factory. So there is a technology. So the harvesting time will be shorter. We don't have to wait 3 months, 2 months to harvest your vegetables. Okay, and then high-tech industries for IR 4.0, we need an expert in artificial intelligence. It's a programming basically. How to program your system, your computer to do observation like you do. We need to have a sensor to represent eyes. We need to have a sensor to represent our touching. This morning we heard about electrical nose is to replace our nose to detect smell. Okay, those sensors we have to program so that they record the right data, so that we can help us to make a decision. What is the next after that? Okay. And then IoT is about connectivity, how the decision is made in the office, but the action, corrective action is taken in the farm. Okay, and then robotics. Robotics, I said earlier, either UAV, UGV, or any gantry system that can work on their own. Okay, and then big data analytics is to analyze all the trend from the sensors. And then blockchain technology is different story. This is for like supply and demand, traceability. Okay, all right. But for our context today, for my context, for farm production, we look at how we integrate sensors with machinery to optimize the crop growth, especially for paddy. Okay. So again, IR 4.0 is about development of multitasking farm machinery, so equipped with multiple sensors. Sometime, like my own project, we put different sensors in the farm. We have moisture sensor, we have pH meter, we have like to produce SPAD, to get to know the chlorophyll content, etc. So different sensors will give different reading to represent different phenotyping behaviors, phenotyping characteristic of the crop. But that is all for observation. Okay, and then which is capable of performing several farm operation and recorded different field data in a single run. So if we are doing agriculture, typically there are many data we have to collect when we do experiment. So for example, we want to know the moisture level of the soil. We want to know, the crop growth, the growth rate. We want to know the chlorophyll content. If you talk about fruit, we want to know the bricks, the sweetness of the crop, right? So many parameters, and then some certain parameter can be measured by certain sensors. So if you are good enough, you may combine in terms of sensing multiple parameters by one system. Okay, so that what they mean by single run or single scanning, single observation, but you have multiple data. Okay, so this modern technology will catch the interest of younger generation to involve in agriculture. I tell you one true story. One of our student, after graduated, he worked as a service provider for drone. So he said to us, after 2 seasons, he get back the money. We call it break even. So I don't know, maybe he has to spend $10,000 to buy a drone. Then he provide a service to farmers. After 2 seasons, he get back the cost of purchasing the money. So meaning that if you have a chance, you have a capital, doesn't mean when you graduate you go for a job, but you can set up your own business, because you know the theory, you know what is needed by crop. So same what happened to my student. He set up a company, he provide a service for spraying using drone for paddy. After 2 seasons, he get back we call it break even. Okay, there is a future or potential work if you are expert in this kind of technology. Okay, next. And then this is very basic definition. I believe you have heard about this few times from those who are doing computer science. But to me, as an engineer, I look at artificial intelligence is a processing center. It's a programming, how to process the input data to make a decision, so that with that data we can execute what is our correction plan system to the crop. So again, but this is by definition. AI is the concept. It's made up of numerous subfields such as machine learning. Now it is a deep learning, which focus on the development of program that enable machine like to imitate human behavior in terms of observation. So the machine can learn, it can understand, can reason, and can then plan and also to act. So means the system can activate your end actuators or your end effectors. Or in this case, maybe if you're talking about irrigation, your system can activate the pump. So when it should irrigate the crop. Okay. So exposed to new data within a stipulated parameters. Parameters is a factor that you are observing on the certain crop. Okay. So application of machine learning is to develop computer programming that can train actuator. Actuator is a device that do the action and a robot to perform a duty as described by a programmer. So based on the input from the sensors we collected during observation. So the theory and the development of the computer system able to perform tasks normally required human intelligence. So if in a typical situation, we have to observe, we have to go to the farm, we have to see, oh, this crop is stunted, or this crop doesn't have enough fertilizer. But you cannot go 3 to 3 every day for observation, right? So now we hire or we ask the sensor to work on that. But we train the sensor, we inculcate to the sensor the same way of how we observe. We make some coding, we say, okay, if the color of this leaf like this is the threshold. If it's beyond this, it is sick. It is healthy. So this is how we train the system to think like we do. This is artificial intelligence. Okay, so such as visual perception, there are many camera these days, RGB camera, hyperspectral, etc., to imitate human eyes. Okay, and speech recognition, decision making, and translation between languages. There are many AI apps you can even found in your phone for language, and then AI or machine learning. Intelligent versus natural human intelligence. So, of course, the machine cannot beat human in terms of flexibility, but we can develop the programming so that the system can as accurate as human in terms of prescribing the parameters, the sample. This is come to the coding. Those who are expert in coding, they can come up with very high accurate programming in making decision on certain observation. Okay, next. So this is a component of machine learning. Again, as I said earlier, I am agriculture engineers. Usually when it comes to machine learning, etc., I will pass it to my collaborators from computer science. Okay, so don't ask me too much on this part. Okay, all right, next. Okay, now I will share with you some example of the system that is developed in Malaysia related to smart farming. Okay, so this is the history of it. Precision agriculture is part of the technology for agriculture, is a management strategy. So that applies a wide range of smart technology, mainly sensors. We talk about smart technology is mainly sensor to collect, to record, to measure, to process, and to examine data or parameters of the crop to guide targeted action. So what is the corrective action we want to take after we know the condition of the plant. Okay, so the progress that efficient, it has to be efficient because a machine do the observation and then increase productivity and sustainability of agriculture procedures. One thing that is very obvious between machine and human is human, after some time, we subject to bias. We tend to get tired. We tend to lose our concentration. Okay, but when you train a machine, they don't have that issue. If they will keep doing the work. So in terms of accuracy, a machine may have a consistent accuracy as compared to human. And human, after 4 hours working, they will be tired. So their judgment is not consistent anymore. Okay. So again, PA, precision agriculture, is just, this is to compare between precision agriculture and smart agriculture. Okay, so PA is taking, like when we do mapping, we do a piece of land, we know which corner has more fertilizer, which corner got less fertilizer, so that when we go into that field, we know this area should get this amount of fertilizer, this corner with low fertilizer, low fertility should get more fertilizer. It comes with, we call it variable rate technology. Okay. So this is, we will understand better the context of the area where we work on. Okay, so smart agriculture refers to the application of IoT when we can do remote sensing, remote observation, or remote control, and IoT integrates a series of existing sensors technology. There are many types of sensors, so different people use different sensors. Okay, to collect real-time data and connect sensors with smart machine so that the field management will be a data-driven and data-enabled system. Okay, so the real-time intelligence system is an important feature to carry out farm operation, which is always subjected to unexpected environmental change due to unfavorable weather or diseases. So this feature is very important for us to build autonomous vehicles because we have to install in their brain what is the path, the condition of path of their navigation path they are going to go through. Okay, they have to understand the field condition. Okay, next. Okay, this is three components. If you talk about precision agriculture in agriculture, precision agriculture for paddy production, we have three components, three main components. The first component is about guidance technologies. This is for autonomous vehicles. So under these guidance technologies, something to do with machines, something to do with tractor, combine harvester. Okay, so either we go for control traffic farming. So means we already have a well-defined navigation path, well-defined route for the tractor to move on. Okay, so control. And then number two is machine guidance. So like active sensor. So when the tractor is moving, they know there is a drain over there or there is any obstacles, they will avoid. Okay, and then also we have a driver assistance system. This is for guidance. Number two is a recording. This is for mapping. I think if you are doing agriculture, you are very familiar with yield mapping, soil mapping, right? This is a mapping. So we do soil mapping, or we can do canopy, like if you have NDVI, there is all those are mapping, either using drone or ground truthing. Okay, so soil moisture sensing. So when we do that sensing across the paddock, across the farm, so we put them together on GIS on the map, then we can see the variance, a variation between end to end within the field. What is the variation? This area is high fertility, this area may be low fertility. This is under recording technologies. Okay, and then all this technology is supported by GNSS, or we call it GPS lah, for mapping satellite. Okay, then the third one is reacting technology. This is where you have sensed the condition. Let's say you have for example, you grow chilies. You grow chili, so you have a soil moisture sensor in a polybag. Okay, so when your sensor detect the moisture level in the soil in the polybag is getting less, is is below your threshold, then it will activate the pump to pump the polybag. So this is a reacting technologies. So we call it a variable rate. If you talk about irrigation, it is variable rate irrigation or variable rate weeding, or that one variable rate technology. So means we supply crop input, mainly fertilizer or water whatsoever, according to the need, to the specific amount which is needed by the plant. Because along the way, previously, traditional farming, we go for blanket application. We have, let's say, we have 1 hectare, 1 hectare of farm. So we just blanketly apply 200 kilogram of fertilizer. By right, we should understand even within 1 hectare of land, the fertility is not the same. Maybe this corner, because it is close to the river, it has higher fertility. So then it doesn't need more fertilizer as compared to the another corner. So agriculturists, they acknowledge that system, that concept. That's why they will go for variable rate, meaning you put the right amount of chemical at the right place at the right time. You do not simply put the same amount to all crop. Okay, so we can save fertilizer cost there. All right. Okay, so this is the component of the precision agriculture. VR mean variable rate. So we put the right amount at the right time and the right place. So we can save crop input. Then we can increase our profit when we reduce our production cost. Okay, next. So for precision agriculture for paddy, but my team also work on oil palm and cocoa. But today I'm just sharing about paddy. So there are 5, we call it stages in paddy production that can be integrated with sensors. Okay, the first is water management. I believe you had heard about smart irrigation to control water. Paddy is very sensitive to water, so we have to maintain the water supply to paddy. And then land preparation. So in paddy condition, the main thing is the leveling. We need to have a very level condition so that the water level will be the same. And also when we do tillage, the soil must be very, very fine, okay, very granular, very fine. And then it comes to seed application. There are 2 methods being applied. The first one is broadcasting. We call it tabo, broadcasting, or we can use machine transplanter. But in Malaysia, majority of farmers, they use broadcasting. Okay. And then under crop management is about pest and disease control. It comes with fertilizer application, it comes with pesticide application, and then under crop management, they use a lot of sensors, especially to detect the presence of disease. So some of them use drone to see the NDVI, so then they can see if the crop is under stress or has been affected. Then if they are, they will activate the spraying operation. So that is for crop management. And then for harvesting. Harvesting is also important because most of the losses, field loss, happen during harvesting. So this is one of my focus area. So how if we can reduce the loss, so we can increase the yield. Okay, next slide. So, okay, because I want to show you how important the machinery. So in Malaysia, we can say that 100% of the paddy production has been mechanized. We use machinery. Like for land preparation, we use tractor. We no longer use buffalo or cow. Okay. For harvesting, we use combine harvester, 100%. But I know in some countries, especially those in a remote area with small plot size where machinery is not able to access the area, so they still use buffalo manual. Okay, but in Malaysia, this is the situation. Okay, right. So you have to understand for paddy production, there are a few field farm operation involved: land preparation, transplanter, sowing, fertilizer, chemical, harvesting, and all of these operations can be digitalized. We can do intervention with the AI. This is my team. The aim of my team, we are trying to install whatever sensors to optimize the operation for all of these farm operations. Okay, next. Okay, and then this is We have studied. This is our team members from all those field operation. Then we understand that harvesting is the most critical part. Harvesting is the most critical part and is the operation that require the highest energy. So you understand if require the highest energy is for them is a fuel, mean this is the operation that costs a lot for your production cost. So we have to find a way how to minimize that so that the production cost can be minimized. So the profit to farmers can be increased. So we divide the operation into first tillage, second tillage, third tillage until slashing. This is the common machinery operation, okay, for paddy production. Okay, next. Okay, now I will share with you three scenario of the AI-driven technology that we has been applied in Malaysia. Either it is at the data here based on the research, but the extension work has been done by this agency. Okay, so the first concept we apply is the potential of implementing smart agriculture. Okay, is observed to be more viable if you are talking about big area. It's not justified. It's not economic to have machinery, to have AI sensors, etc. If you only work on 1 acre area. Okay, so this technology, precision agriculture technology, is more economically viable if you work in a bigger area. Okay, and then for in this context, GIS-based land survey was carried out to obtain the land leveling index. So, as I said earlier, for paddy field, the land must be very flat, equally, because if it is undulating, when you put seed, so some seed might be inundated by water. Okay, this is important. So when it is inundated, it will die. It cannot survive. So in this work, so they divide they prepare a map, a field map. So they divide a grid. Later I will show you the diagram. So 10 times 10 grids, and then they divide the area according to the level index, either high, even mean flat, high or low in terms of the levelness. Okay, so what happened is for the low category area, they put extra seed so that they can maintain the crop density, of in that paddy field, because there is high risk of the seed in low category not to survive, because of they are not fully inundated. Okay, so later by using site-specific or variable rate technology seed application method, so based on the mapping, the seeding will supply normal rate for even area, and then higher rate for low area, and less for high area. So that we can maintain the crop density across the paddy field. And then quantification of the site-specific nutrients status of soil will allow nutrient application to be done accurately, because we have a map. And then later they use drone to get the aerial images to see either we have that density, consistent density, crop density across the field. And then it can also be done on site with sensors. We call it ground truthing, that work in tandem with GPS, which enable mapping system that will fed into the nutrient distribution model. Okay, so next slide. So this is the step taken in a diagram. So first we have to do the land leveling, and then we categorize the level of the soil, and then we feed, or we put fertilizer, the seed according to the level, the category of the levelness, and then we apply the seed, and then later on we use drone to monitor either we got the right crop density across the paddock based on these three different treatment. Okay. Okay. Next slide. Right. The second, the second technology we have developed, by this agency is the application of fertilizer. Okay. Variable rate technology in fertilizer application that offer nutrient sufficient nutrient specifically to meet the plant requirement. So because as I said earlier, traditionally we go for blanket spraying, which may lead to uneven application. Okay, but now we use variable rate technology that target the crop, then they will supply fertilizer at the right amount at the right time. Okay, so under this study, under this project, this variable rate fertilizer system work based on the green area index. So they have a drone, they do the mapping. So that will enable, so that we can have a classification, which area which is more greener, so they are more healthier. They have enough fertilizer as compared to the area with less greener. Okay. So this system we attach with GIS for mapping, process to obtain soil plant analysis, then SPAD is for chlorophyll content, GAI is the green area index, that will be used to project a GAI for the treatment map. So when we have the map, so when we apply fertilizer, we follow according to the map. So the area with lower fertility will receive more fertilizer, and the area that is already good in terms of fertility will supply either no fertilizer at all or with a reduced amount of fertilizer. So this method has reported to save 17% of the total fertilization cost and increase about 20% efficiency over the conventional fertilization method. This is a proof of how AI help in terms of improving the production of paddy in Malaysia. Okay, next.
Excuse me, Dr. Nazmi, we have 5 more minutes.
Huh, really?
Yes, for the presentation.
Okay. So, okay, next, I want to share one more project. Next slide. Okay, this is common. Next slide. Okay, the current project that I work on is a grain loss monitoring system. Okay, maybe I can skip this one. Next slide. Okay, so grain harvesting. Now, this is typical machine, combine harvester we use in Malaysia. Is prone or subjected to grain loss due to the operational. Okay, it was recorded that during harvest, the losses, grain loss can go up to 14%. So you imagine if that plot should have 100 ton, okay, because of 14% loss, they can only go for 80, means 40% loss. So it's a lot of losses to farmers. So grain loss measurement and monitoring in combine harvester is important, but traditional method is time consuming. So in my project, we develop grain loss monitoring system, real time. Okay, next. So this is a research problem, as I said earlier, grain loss, very significant loss to farmers. Then according to the literature, acceptable grain loss is only less than 3%. So if your machine, whenever it goes to the field, if the losses is more than 10% or something, it's not okay. You have to do something with how you operate the machine. Okay, next. So this is a conventional method of measuring grain loss. We also did that to calibrate with our sensing system. Okay, very tedious, require many manpower to measure the grain loss at the back of the tractor. Okay, next. So this is the workflow of my system, grain loss monitoring system, where we use Arduino IDE, we use piezoelectric sensors for the detection of the grain loss, then some programming involved. Okay, this is hardware and also the integration with the software. Then we set a threshold, what would be the weight of one single grain because sometimes panicle, also straw, also ejected from the combine harvester. Okay, next. So this is the overview of the system. We make it something like IoT, where we can get the data from distance. Okay, next. So this is how we install the system on the combine harvester, the grain loss system. Okay, we use that aluminum plate with a sensitive plate to detect any single seed that come in touch with the plate. Okay, next. And this is the arrangement of the stainless steel plate we use for our grain loss sensor. Next. And this is the circuit of the system. Okay, you can read through this letter. I can share the slide with you, no problem. Okay, next. So okay, this is how we calibrate our system in the lab. Okay, we have like pure grain, grain with debris, grain with we call it straw, so that different condition have different weight in terms of grain. Okay, so we set a threshold so that only fresh grain can be counted to consider the loss. Okay, next. So this is the system we install at the back of the tractor, combine harvester. Then you see that LCD box. That LCD box come with buzzer. So when a combine harvester driver drive a combine, and then suddenly due to maybe higher speed, the loss is exceed the threshold, so the buzzer will beeping. So it means the driver has to stop or reduce the speed or fix it. What is the problem? So this is a real-time system that we developed to assist the combine harvester driver to reduce the loss during harvest. Okay, next. So we also do the calibration procedure. We found that the system that we developed give us 85% in terms of accuracy. Okay. Okay, next. This is another project of my PhD student using AI and IoT, but I can summarize the project. This is to detect the quality parameters of the compost. Okay, next. So these are the parameters we measured simultaneously, real time. So we just put our a bundle of sensors, so it can give us the reading of temperature, moisture, CO2, oxygen at one time, a single run. Okay, okay, next. So this is the system we developed. They have LCD, then they will give us a real-time data. What is the condition of compost at that time under the compost? Okay, next. Okay, this is the architecture of the system. I'm not going to describe about that. You can have a look later, but this is just to show how we use AI, sensors, IoT for monitoring, real-time monitoring of the compost quality. Okay, next. This is list of components you see to come up with sense smart, well, artificial intelligence system. They need to have an integration between hardware and software. Okay, all right, next. This is how we do. We connect all the sensors, the reading, we process, then we display on the LCD for a real-time monitoring. Okay, next slide. Okay, time's off. Okay, then you can read through this. Just challenge. Okay, next slide is a challenge. Some adoption strategies. Next slide. Potential, possible. It's like an academics. What you can do to increase the efficiency. Okay, next. Okay, way to go. If you have a courage, you may invest your time in this area, because this area have a future. Okay, okay, next. Conclusion, next. Some recommendation you can read through. Okay, next slide. Future farms, ideally. And okay, thank you very much.
Thank you very much, Dr. Nazmi. Give a round of applause for Dr. Nazmi. Okay, thank you so much for the insightful presentation. a little bit to summarize like what we have been listening so far, it was very interesting. Dr. Nazmi emphasized how the industrial revolution is indeed has moved on, but unfortunately for agricultural sector is still below the expectation. Correct, Dr. Nazmi? And while the need to upgrade the technology in agriculture is inevitable. And also the connectivity is the key because we as agricultural engineer, maybe we don't really understand on the like computer science part, but that's where the collaboration should happen. And the third one that I can tell is like the examples of successful application of precision agriculture in Malaysia. This is very interesting. Dr. Nazmi pointed out several examples. The first is like using site-specific of variable rate technology for the seed application method and also VRT in a fertilizer application. And the last one that catch my attention was like the your recent project on the grain loss monitoring system real time because I also quite familiar with the harvester and in Indonesia, if I'm not mistaken, we set like 5% loss as the maximum for the loss during the harvester and harvesting process. And yes, it's like the biggest where the losses happen. So this is very interesting project with the urgency that is very high, I think. Okay, the next one is I open the discussion for the both offline and online participants. So maybe we would like to have maybe one question and answer, or how would you like to have it?
I will answer one by one.
One by one. Okay, so one by one is better because it's focused. Okay, so anyone who would like maybe first for the offline participant here. Okay, first Michael, and then any other. So I could take a note of the names. How about the offline participants? Maybe you could have it in the chat. Okay, I have one question in the chat already. So maybe we can start with Michael and then I will read the ones in the chat. Okay. Please use the handheld mic. Okay.
Check. First of all, let me introduce myself. My name is Michael Carlo. I'm from Gadjah Mada University. And I really appreciate on your take about collaboration because this AI things is a large industry, and as an agricultural engineer ourselves, we need to collaborate with many science major. And my question is, if we want to improve ourselves, we need to innovate, right? But the young innovator doesn't really have fun about it. So when we want to innovate something, we don't have any funding, and we can literally create anything if we don't have money. So how do we start to look for fun? That's it. Thank you.
Thank you. Mr. Michael from where? Gadjah Mada. Oh, from here.
Yes.
Cakap Melayu saja. Cakap Jawa. Ngomong. Okay. All right. I will share the incentive or initiative taken or I mean offered in Malaysia. So what the government is doing to encourage more younger generation to enter the industry, they are providing grants and also incentive. Also, okay, first, if you are, let's say, a fresh graduate, you finish your study, you want to join into this kind of technological things for agriculture, there is like, it's a one-off gift, 20,000 ringgit to set up a company is incentive. It's not a loan, you can have it, but you have to make sure you have a business plan properly. And then some agencies, they also have a scheme like incubators. When you go to in the industry, I mean the agency, they groom you. They have like incubators, you know what I mean? They in-house training until you are independent, then you can run your own company. And then we also in the department, we was approached by a company actually. They said they have a contract with a biggest plantation industry, they want to produce more pilot for drone. So any student who, because you are talking about how to encourage youngster to involve in agriculture, they say they will provide a training, they will provide a drone, but you work for them. They are a contractor, you will work for them independently throughout Malaysia. So you see, the government is supporting those who are investing their skills in this industry through grant, and then the related agencies also offer training, and even industry. They are in a dire need for people because they got a job, but they don't have talent. So this is, but it is a monetary incentive to encourage, you know. But again, I told my student, if you are agricultural engineers, you are not going to be a farmer. You are not going to hold a hoe, cangkul, to do it manually, right? You are trained to be a manager. You will be a manager of the estate. You might be the owner of the service provider. You might be somebody because you are trained to be engineers. So this is how we try to say to them, don't be afraid, don't be shy to call yourself as agriculture engineers, because you are not going to play with snake anymore. You just sit in the office, manage everything remotely. Am I answering your question?
I can conclude the answer. So, if I can conclude the answer, so other than looking for government funding, we need to find like agencies for us to share our project so that we can make a fund and of course advancing agriculture in the world like that. Okay, thank you for the answer.
Okay. Okay, thank you, Michael, for the questions. Before we move on to the online questions, maybe okay. I'm sorry, I didn't see your name. Could you tell your name and where you are from? Okay.
So good afternoon. I'm Anis from UNIMAS, University, Malaysia, Sarawak. So IoT in agriculture relies on the internet for real-time data transfer and remote control. So what if the connection is unstable? Will the data collections and operations will be delayed or lost? And if yes, how can we tackle this issue?
So thank you very much, Miss Anis, Unimas. Okay. Um, this is real issue. One time we were approached by one company, corn plantation company. They want to have a IoT system in the remote area to monitor grain corn, uh, jagung bijirin, okay, for animal feed. So the issue is the connectivity, because IoT is about connectivity. It needs the internet. So what happened? Some area is not under the coverage of the signal, but with the current technology, they have LoRaWAN. This is also low cost one, but in Malaysia there is a company. There is a company like, if I'm not mistaken, DG Celcom or something. They can hire. We can rent antenna. It's a portable antenna. So let's say if we have a need in that area in Johor, so even that company also, we know that company, service provider, they say if you have a need, then we have to justify how much the usage of that. Then if it is justified, the area is big enough, they will go and install a tower. But it is definitely, without internet, you cannot go online. It will be offline. It will be not, it's not real time. The sensor can record the data, but it cannot access online, right? So you may go once a week, once a month to extract the data to see the trend. But if any particular area have no connectivity, there is a company in Malaysia they can come and provide that uh, tower, temporary, portable tower. Okay.
Okay. How Anis is okay? Okay, thank you so much. Uh, okay, while waiting for the offline and another online question, I would like to read one questions online, Dr. Nazmi. We have question from Tan Yusian. Uh, he or she is from UPM. And good afternoon, Dr. Nazmi. Your lecture are interesting and insightful. I have a few questions regarding your presentation. In Malaysia, we have introduced a variety of technology in agriculture. However, the percentages of technology adoption is quite low, especially for small-scale farmers. Hence, I would like to ask what is the methods or solution to ensure that the small-scale farmers can and want to use the modernized technology in their farm in order to increase the food security level of Malaysia. Maybe you could ask, because she already has two questions, so maybe this one first.
This is the first
This
one.
is the first one.
Okay. In my first slide, second slide, when we talk about common challenges in the adoption of technology, is the smallholders is one problem, but the elderly is second problem. So in Malaysia, what we are doing, when I say we refer to the government agency, we are moving towards the cooperation. Um, uh, we call it koperasi in Malaysia. Maybe it is a corporation, which means that the government agency will take over the land. They will manage uniformly, but the farmers is like the government is hiring the plot from farmers. So farmers do nothing. Everything is managed by the agency for fertilizer, harvesting. But once the crop is sold, they get money. Okay, that is number one. Number two, among farmers, they create a group. A group. This happened in Kedah. They create a group, so they appoint one leader, manager, to manage. So mean they do not manage their own land individually, because for paddy, you have to make it as a regional, like for irrigation. Once we release the water, it will go to all plot. You cannot say, no, no, I'm not ready to get water. No, we cannot, because it's one single management for one regional. Okay, so they come up with association. Then the management will be done by one manager. Of course, that manager will get incentive, and then the farmers will get the pay according to how much yield the plot produce. So single management and the big area is better, but still there are some farmers who don't want to join that incentive, then they are left behind. They left behind, then their yield may not be so good. Okay.
Okay. And the next question is, in the future farming will be integration of AI, robotics, and automation. May I know what is the role of agricultural engineering or agricultural students in the future farming system? Will they be substituted by AI and robots?
Okay. Labor will be substituted with machine, but agriculture engineers will remain to be a controller for the system, manager. Okay. So don't worry with the development of this AI, because AI is human created system. So if human is not there, the system doesn't work. So we will be the owner of the system. We will be maybe the creator of the system, but if you are trained to be agriculture engineers, or you are trained to be agricultural officer, or maybe data scientist to look after this crop, so you are needed. What is not needed, or what is going to be eliminated slowly, is the groundwork, is the ground staff. Okay, because like planting will be done automatically, crop monitoring, instead of people go from pot to measure, to monitor, but later will be replaced maybe by drone, by UGV. Okay, so the operative part will be replaced, but the management part will remain. So don't worry. Okay.
Okay. So yeah, that's unusual. Don't worry, because we have I mean, we will move up from the not the doer, but maybe we are the creator, the manager. Okay. Uh, I invite once again. Okay, we have Putra, correct, from Philippines.
Yes. Um, Good day, sir. I'm just gonna read the question. In the Philippines, rice is a staple food, but rice farmers face a double threat: powerful typhoons this and farmland is being lost to city growth. Because of this, the Philippines is relying heavily on imports, which will not be helpful in the long term. While research by my professor suggests that growing tougher crops like sweet potatoes or cassava could help replace the staple food. Farmers are unsure how to switch and if those new crops will sell. So my question is, beyond suggesting new crops, can AI tools help existing Philippine farms better survive typhoons and floods and still grow more rice even with less farmland available due to city growth? Like, can AI give early warning signs for them to harvest their crops?
Okay. So generally, because we don't have typhoon problem in Malaysia, but we have drought. We have drought problem. Sometime at the paddy field, when drought happen, no water in the paddy field, then the crop dies. So because of that need, so the university work with the agency to come up with, we call it drought tolerance variety. So maybe in the Philippines, if typhoon is your main threat, you may come up with what typhoon tolerance variety something. But it's different, I think, because typhoon means the strong wind that will collapse the crop, right? Um, Maybe one of the options to go to variety, genetic or breeding engineering. But the second thing is, um, like in Malaysia, we grow crop twice a year. But I heard in Jakarta, Georgia, just once a year, because they alternate with bawang apa chili yeah. So if the area is limited, what we can do more cropping, more frequent cropping. So in Malaysia now we are moving towards, instead of two cropping per year, which means four cropping per 2 years, we are pushing to have five cropping cycle within 2 years. Uh, so maybe in the Philippines, if the typhoon season is consistent, so you can alternate. Maybe okay, this is a free typhoon season. You can have crop paddy, but in the typhoon, season, you can go for another crop that is more tolerance to typhoon. Uh, but again, go for intensified cropping when the condition is safe. But again, I said, go for variety. But again, maybe I'm not. Typhoon is a strong wind that will collapse the crop, right? I do not know if there is a possibility to have a more strong paddy panicles that can withstand strong wind, or maybe if we can have a variety that in Malaysia they call it um, fast matured crop. That means if we have, say, for normal paddy, it will take around 125, 130 days. So that variety may take about 100 days, then can be harvested. Then you can plan to plant before the forecasted typhoon to happen, because typhoon can be predicted in advance, right? But again, there is my general opinion, because in my country we don't have that problem. I hope we can help to suggest some solution. Thank you.
Okay,
Pak
thank
Iwan
you.
ada nak tambah? Any comment from you, expert?
Thank you, Prof. Nazmi. I'm from Food and Beverage Association in Indonesia. My name is Yuan. Glad sharing from you about downstreaming from farm. But like you already shared, for us it's a new about the fourth F is a fiber for our clothing. Also is a from farm. Is correct, Mr. Nazmi? Yeah. Of course, your country is more advancing in downstreaming. But my question is, how about the fruits, vegetables grow in Malaysia to completing the staple food like paddy? And how the farmer have a land or is a managed farm, the land belong to corporation? Just for comparison between Indonesia and the way you manage your farm in your country. Thank you.
So thank you, Pak Irwan. So two questions I can capture. The first one is alternative crop to rice. Okay, it was if you look at SDG, UN SDG, the number 12 is about responsible, consumable consumption, and also production. So there is a campaign has been around in Malaysia from Ministry of Health for the go for right portion. So we want to reduce the waste. So if you go to Malaysia, there is a TV advertisement, suku-suku separuh. What to say? How to say that? It means you take rice not in big portion. Just take one portion of rice because this is carbohydrate. GI, it make you fatty like me. I eat a lot of rice. So you go for more vegetables, go for more protein-based product. So there is one campaign. So by that campaign, if successful, so the reliance of people on rice will reduce. So they have. Secondly, in Malaysia now we are modernized. So some people don't eat rice; they go for like Western food, spaghetti, macaroni, and etc. Bread in the morning. The lifestyle is changing. In terms of fruit, previously they have promoted like ubi, konjac. Konjac. Englishnya apa?
Konjac.
What is English?
Amorphous from the amorphous tuber, right?
Tubers.
Yeah, from the tubers.
Tubers, okay. They are promoting tubers. They are promoting cassava as a fruit to be taken alternate to rice. Then we have vegetables, fruits other than rice. We have banana, tubers. What else can be replaced for carbohydrate? Sagu, for in Sarawak they have sagu, and many more. But also corn, also use. But I think the main effort in Malaysia now is by that campaign to only take reasonable amount of rice, not too much, but balance it with protein-based food like chicken, fish, and vegetables. Okay, the second question is about ownership of the land. Some part they have a consortium. Some part, majority still belong to smallholders. But these smallholders, they have either we call it consortium or they have agreement among themselves. One area they will appoint one. We call it one manager. So we call it broker in a local term. So this broker will deal with service provider, will deal with any agencies. So any operation, any harvesting schedule will go through that broker. But the ownership of the land, majority still belong to smallholders. But they are educated. But they are also, the government has also opened up new estate farming. This is fully owned, fully managed by private or by government agency. So this is under uniform management.
Okay. Thank you, Dr. Nazmi. We have like 2 minutes left for the discussion, and we have one question remain in the chat box. I will read the questions, and maybe you could answer, and also adding with the like a closing remarks for today's session. So the question is, hello sir, it is from Faria. Hello sir, I have a question. Why is modernization necessary in the agriculture sector, especially in the context of Malaysia's aging farming population and declining skilled labor?
So the simple reason is to attract younger generation to join the industry. So we have to brainwash their mindset that agriculture is no longer difficult industry, is no longer dirty industry, but this industry also can be approached by robotics, can be approached by advanced sensor like what happened in US, right? So even you can drive a tractor by wearing headphone, you can listen to the song. And I tell you, the tractor now comes with cabin. It's no longer without a cabin. So you are not exposed to the sunlight anymore. You are well protected under the current modernization. So it is important so that we can get more younger generation to involve in this industry, so we can reduce our dependency on foreign labor.
Okay, thank you so much, Dr. Nazmi. One last time, would you like to add something for the closing remarks?
Okay. So as a conclusion to all of you are here, I think you should be proud of yourself, because you are, maybe soon you will be part of that 5% world population involved in agriculture. But it is not only farmers to claim themselves as a producer, but if you play your role as a data scientist, you play your role as agriculture engineers, you work with pests and disease, you work with formulation of pesticide, the breeding, variety, and etc. So those will contribute to a better, more efficient fruit production in the world. So remain in your pathline so that you can be one of the player in the food production in the world. Thank you.
Thank you, Dr. Nazmi. Please give a round of applause for Dr. Nazmi. Okay, that's the end of our session for this morning to afternoon. I will get back to the MC. Thank you very much.
Thank you so much to Associate Professor Dr. Nazmi Madnawi for being an insightful lecture about AI-driven innovation for sustainable paddy production, a Malaysia perspective. We would like to give the appreciation certificate that will be given symbolized by our moderator.